Finally, I'd like to consider how we might use the HP10B calculator to help us solve some of these time value of money equations. To this point, we've taken a look at actually using the equations themselves. Now let's look at how we might think about using the calculator to help us solve this. The calculator first needs to be understood in terms of its construction and convention. And while you'll learn to use the calculator in your business fundamentals course, let's consider just some of the items very simply. First, when I pick up my calculator, and I use this calculator often, the very first thing I do is I clear the entire register. I don't know what was on it the last time I used it. I don't want that tainting anything. And I do that by hitting the red or secondary key and C. And that then gives me see all or clear all. So red key, secondary key, then activates the red commands or functions, so I've cleared all. The next thing that I need to do with this calculator is I need to tell the calculator how many periods per year we're dealing with. So if it's annual, it's 1 period per year. If it's monthly, it's 12 periods per year. If it's daily, it's 365 periods per year. And I do that by, again, hitting the red secondary and then red PYR and then 12. If it's monthly, or 1 if it's annual, or 2 if it's semi-annual, etc. So I first have to go ahead and clear the calculator. I then set the periods per year, and now I can start to use some of the different keys to help me solve the equation. And in this case, I've got a present value key, and that present value is, not surprisingly, present value. I have a future value key, similarly is future value. My beta T, or remember that was simply some cash flow, which might be a payment, is the payment key. R is expressed as some interest rate per year, and it's the I divided by YR key. And then T is some time, and we don't know the number of units of time, so the calculator looks at that as N, so we have N. Let's take a look briefly at how we might use this. We're going to think of each of these as being 5 expressly unique variables. And if we have 4 variables, we can solve for the 5th. So in this case, if I use the calculator and tell it that we have an annual transaction where my present value is going to be equal to 0. Here, let me get rid of these. It'll make it a little easier for us. My present value is going to equal 0. My beta T or payment is going to equal negative 200. My N or T is going to equal 6. My R or I divided by YR is going to equal 0.04. And I'm going to solve for future value. Well, first of all, I think we better understand some of the convention inside of the calculator that helps me know why I put a negative in front of this 200. This calculator has an input-output function, and it thinks of these as something coming in as positive, something coming out as negative. So in this case, if I've got a beta of negative 200, that's a payment going out. So this might be an investment of $200 a year into something. And so that's a payment coming out. This is going to return a positive value. Well, if you think about the equational form, if we have a negative on one side, we were going to end up with a negative on the other. But in this case, we're going to put in a negative and we're going to get a positive. Not because that's mathematically correct, but because of the input-output stack or flow structure architecture used by this calculator. We're having $200 going out. So we're making an investment of $200. We're spending the money. It's negative. It's leaving us. And we're going to find that there is some number going in. If I said 0 present value and negative, so I press the plus minus button, I change the sign, negative 200, and that's going to be payment. And then my rate or interest divided by year of 0.04, which the calculator wants to see that as 4, because it thinks of it as a whole percentage. So 4 I divided by YR, And then even though I've told the calculator already that this is 1 period per year, I'm now going to tell it 6 in because it's 6 years. And we would find that the calculator would return a value of $1,326.60. So let's go ahead and think of this with another example. Let's suppose we're receiving a loan for $1,050 today. That loan is going to be paid back at an interest rate of 6%, and it's going to be paid back in 5 years. Just a one-shot transaction. Well, the first thing I'm going to think of is I'm going to clear my register. So red, see all, clears the register. I'm going to set up my periods per year as 1. So I want to say 1 red PYR. I think a few moments ago I suggested that that was red PYR and then 1. That's incorrect. I apologize. It's the number of periods per year, secondary, and then the red period per year command. I know that I've got a present value of $1,050. It's positive because it's money I'm getting. It's a loan I'm receiving. I don't know what future value is. My beta, I'm going to say is 0. I'm not making payments each period. I'm just going to have some lump sum payment that I have to receive at the end of the period. My rate is going to be 6%, and my time sequence is going to be 5 years. So I can go ahead and, having set up my periods per year, I can say 1,050 present value. I can then say 0 payment, 6% interest per year, and 5 years. And it will return the future value for me of $1,405.14. And it'll return it as a negative. So if I got the loan of $1,050 today, 6% interest, 5 years, I would have to make a lump sum payment of $1,405.14 at a point in the future. So another example might be, what if we have a mortgage that's $200,000? We're considering a mortgage of $200,000, payable in 30 years in monthly installments, and it's at 3.5%. Well, the first thing I have to do is think about, how does this calculator think? Well, it wants to know how many periods per year. So I'm going to say 12 periods per year. I'll do this after I set my clear all. I'm then going to go ahead and think about the present value of $200,000. It's positive because it's money I'm getting. I'm borrowing money from the bank. What's my future value? Well, if it's a mortgage and I'm paying it back every month, at the end of 30 years, I paid it off, the future value is 0. What are my payments? Well, I'm about to calculate those. My rate is 3.5, 3.5, and my time is 30 years, but I have to multiply it by the periods per year of 12, so it's 360 months. There's an idiosyncrasy to this calculator. Even though we've told it the periods per year are 12, we also then have to tell it the express number of periods. It uses this periods per year construction to think about how to allocate the rate, but we still have to tell it exactly how many periods we're dealing with. And if it's 12 months a year, 30 years is 360 periods. So I can calculate for beta now, or my cash flow, or my payment. I can go ahead and say 12 red PYR, $200,000 in present value. That's positive because I'm getting it. 0 future value. 3.5 I divided by YR, or interest per year, and then 360 in. And once I've done that, I simply press the payment button, and it's going to solve, and it's going to tell me my payment is negative $898.09. And it's negative because that's money I have to pay each month for 30 years at a 3.5% interest rate in order to have received $200,000 in a loan today. What's really taking place here is we're able to give this calculator 4 of the 5 variables. And once we've given those variables, regardless of the order in which we put them, we just have to give 4 of the 5 variables, we can then touch the button and solve for the 5th. We need to make sure that we have told it how many periods per year, and we need to express our number of periods consistent with the number of periods per year that we've told this. I'd like to give 2 more examples of how you might use this. And I'll tell you that the very best way for you to learn how to use this calculator, and especially its time value of money functions, is to play some games or some what-if scenarios. And so I've given you a couple already. I'm going to give you another now. Let's assume you've gone to purchase a vehicle, and you know that you can afford a payment of $150 a month. Payment, so it's going to be negative. You're going to be paying that. And you know that you want to have this be a 4-year loan. So it's going to be 4 years times 12 months because you're paying it monthly. So you're going to have 48 periods. And you know the prevailing interest rates on an auto loan of this type with your credit and amounts and such will be 6%. Well, we know when a loan is finished being paid for, its value is 0. And so with that, how much of a loan can you afford if you can afford a $150 payment? So I think about this in the construction of my calculator. I have gone ahead and cleared the register, red, clear all. Some people call this red button the secondary button, secondary clear all. I then go ahead and say 12 secondary PYR. So I've told the calculator 12 periods per year. And now I'm going to start feeding it some of the information. I don't know the present value. We're going to solve for that. I know 0 future value because the loan will be paid for. 150 change sign payment, so $150 in payment. 6 I divided by YR, and then 48 N. And when I've done that, I can then solve for payment, or present value, and find that my $150 a month will allow me to borrow $6,387.05. Well, if you go to a car dealer and they tell you, hey, don't worry about this, it's $150 a month. And sometimes they don't tell you how much the actual cost of the car is. You and your calculator, in just a few moments' time, you can identify what loan they're asking you to take on, and that gives you an idea as to the price of this. Let's think about yet another scenario. Let's suppose we're going to make an investment towards our retirement. And we're going to do it for a period of 30 years. And the investment is going to be monthly, so it's actually 360 periods. We believe that we're going to receive an interest income or appreciation of 5%. We're prepared to put $100 a month into this. We're starting with nothing in the account, and we want to solve for the future value. So to do this, secondary clears the register. Then we want to go 12, secondary PYR, sets it up for 12 periods per year. And then we're going to start feeding variables. 0, present value. 100, change sign, payment. 5, I divided by YR. 360, N. And when we solve for future value, by simply touching the future value key, we're going to find that the future value is $83,225.86. And this is going to be positive because we put money away, money left us at the rate of $100 a month for 30 years, and it's returned to us with 5% accumulated interest as $83,225.86.